Today I'm going to show you how to use the multi-scale cylinder correlation module, which works pretty much the same way as the classic cylinder correlation module, except you can define several cylinder templates. Whereas with the classic cylinder correlation module, you can only try to match one single cylinder template. So here's a dataset of polyester fibers with different levels of diameters. The big ones, the medium ones, and the small ones. We can even visualize the dataset in 3D, so you can see how all the fibers are oriented in space. And as you will notice, all the fibers are pretty much aligned the same way. They are rather straight. The only difference is that we do not share the same level of thickness, therefore diameters. So once we're here, we can start using the multi-scale cylinder correlation module, which is located in the extra section of your application. And once you have created it, you can start setting all the characteristics of the cylinder templates you want to match with. But the first thing is to set how many different cylinder templates you want to try to match with. And in this case, we will use only 3 different cylinder templates. One for the big diameters, one for the medium, and the last one for the small ones. But the characteristic of the cylinder templates remain exactly the same as the one of the classic cylinder correlation module. So for instance, there is the length, the inner radius, the outer radius, and so on. So once you have set all the characteristic of the cylinder templates, you can start launching the computation. But as the computation of the cylinder correlation can be rather long, in this case it takes approximately 20 minutes, we're skipping this part and jump right to the results. The module generates a correlation map as well as an orientation map, and both maps must be connected to the trace correlation lines module to generate the spatial graph representation of all the fibers that have been identified by the module. So the settings is exactly the same as the one you use when you use the classic cylinder correlation module. It will generate the spatial graph representation, and you can eventually visualize the spatial graph with all the customizable option and characteristic you want to use. So for instance, here I use a coloring by tortuosity to make the not so straight fibers stand out compared to the others. And you can also visualize the original datasets to check that all the fibers correspond to the original dataset. I hope you enjoyed. Bye.